Welcome back, students. In the last class, we discussed the layout managers concept and we covered three layout managers: flow layout, border layout and grid layout. So coming to the next layout manager, grid bag layout. Grid bag layout. Already in the last class we have seen grid layout. So what is the difference between grid and grid bag layout? So when you can choose grid layout and when you can choose grid bag layout. Suppose if you want to develop matrix kind of shapes, then you can choose grid layout. Suppose we have one matrix representation. So let us take a 2x2 matrix. 2x2 matrix means 2 rows and 2 columns. It have 4 cells. Each and every cell have a particular component. Each and every cell have a particular component. We can place each and every cell have particular component. Component means like touch wheel, test area, button, checkbox, labels, everything. So next one, coming to the grid bag layout. So grid bag layout means suppose if you want to place a particular component in particular cell. If you want to place particular component in particular place, then you can choose grid bag layout. Suppose let us take one matrix. So it is also a matrix kind of representation. Suppose let us take one matrix, 3x3 matrix. 3x3 matrix means 3 rows and 3 columns. 3 rows and 3 columns. Here we have 3 rows and 3 columns. Suppose if you want to place particular component in particular place. Suppose these positions are 0, 0, 0, 1, next one 0, 2, 1, 0, 1, 1, 1, 2, next one 2, 0, 2, 1 and 2, 2. So it is 3x3 matrix. So if you want to place particular component in particular place, suppose I want to put one component in 0, 2 position. Suppose I want to put one component in 2, 1 position. So it is flexible to place a particular component in particular area. So it provides the then we can choose grid bag layout. So compared to grid layout, grid bag layout is more flexible. So it is more convenient to users. Sometimes we want to put a particular component in particular cell, then user may choose grid bag layout manager. So it is more flexible than grid layout. Grid layout means it arranges the rows and the columns. So each and every cell have a particular component only. But coming to the grid bag layout, so if you want to place particular component in particular place, grid bag layout will help us to put particular component in particular place. So it is more flexible than grid layout. Next one, it allows the components span over multiple rows and columns. So it is also nothing but collection of rows and columns. It is also so to fetch to develop matrix kind of representation. So it consisting of number of rows and number of columns. Let's coming to the next one. So it also enables us resize the components by assigning appropriate weights to them. So we can resize the component. Suppose we can resize the component. Suppose here 0, 2. So it is one cell, it is one grid and it is one grid. Suppose I want to mix these two grids in one grid. So we can mixing 2 grids as one grid. So we can mix 2 cells as one cells. So we can extend the length and height of these cells. So grid bag layout will provide this feature also. Next one, grid bag useful is you can specify the relative placements of component by specifying their positions with the cells inside a grid. So already I told you, suppose if you want to put particular component in particular place, then you can choose grid bag layout. Suppose I want to put one component like button in left position or right position. So there are number of regions are there: south, east, north, east, top, bottom, left, right. So I want to place particular component in one particular region, one particular place. So we can usually place a particular component in particular cell on a container. So it also provides grid bag layout provides this feature also. You can put particular component in particular place and particular grid. Each and every cell have one grid. So each and every cell have one particular component. Each and every cell have one grid. Let's coming to the next one. So in a grid bag layout, each component can be difficult to size and each row in the grid can have different number of columns. So if it consisting of number of rows and columns. So suppose if you want to resize the rows and the columns, so it also provides the future. So we can mixing 2 grids as one grid also. So this is why the layout is called grid bag So it is collection of small grids joined together. So we can small cells are there. So we can join as one cell. We can join as one cell. So we can combining two rows in one row or two columns as one column. So we can easily combine together. So next one, the location and size of each component in a grid bag are determined by set of constraints. So here, so there are number of constraints are there. So where you can place the components. These constraints determines where you can place the components, in which cell you can put the component. That constraints defines in the later we can discuss what are the constraints are available. So next one, the constraints are contained on a object type grid bag constraints. So those constraints you can simply say as grid bag constraints. Constraints means where we can place the components, in which cell you can put the component and which region you can put the component, where you can place the components, it determines the constraints. Simply we can say these constraints are grid bag constraints. In the next slides we will discuss what are the constraints. So next one, grid bag, so constraints include height and width of a cell. So it includes height, so height and width of a cell. So what is the height, how many number of rows and the columns are there. So what is, how we can specify the columns and the rows, it determines the constraints of a component. So we can specify the particular alignment. So what is the procedure to set grid bag layout? So the general procedure for using grid bag is first create a new grid bag layout object. So every layout manager generally what should we follow? So we can create a layout manager. So in this one we can set the layout by using set layout method. If no call is made, default layout manager is applicable. Suppose here to create a grid bag layout object and make it current layout manager, and to make it a current layout manager. Then next one, set the constraint that apply to the components. So there are number of constraints are there where you can place the components in a particular cell. So we can set particular constraint in the component, and that will be added in the grid bag layout manager. So next one, grid bag layout defines only one constructor. So here it is a default constructor grid bag layout. So it is a constructor. So in order to create object of the class, we have constructors. Constructor name same as the class name. Already you know that. So grid bag layout defines only one constructor. What is the constructor name? Grid bag layout. It is a default constructor. It does not accept any arguments. Next, coming to the next. What are the methods? So next one, methods. Generally, a class contains what grid bag layout. It is a class. Generally, class contains variables, methods, constructors, and so on. So in order to access the methods, just we have to create an object. With the help of object reference, we can accessing the methods. So every class have some variables, data members, methods, and constructors. So coming to the methods, what are the methods? So here there are one method. However, that you must use set constraints. So set constraints. So we can set the constraints of the components. So we can set the constraints of the component. We can use set constraints method. So generally you know that if any method contains two word, second word, first letter should start with uppercase letter. These all are the naming rules. These are the naming rules for declaring the methods. Next one, so why set constraints? So next method is set constraints. So next, first one is a default method. It does not take any argument. Next one, it takes two arguments, component and grid bag constraints. So here, component is the component, while constraints specified by constraints apply. So where are the constraints? So where you can place the components? Those determined by the component object. So component. Next one, constraints. Where the constraints apply on the component. So how to set the constraints in a component. So how we can specify particular component in particular place. So these method will help us to set the constraints and the components of a particular component and particular cell. Next one. So here the key successfully using grid bag layout is the proper setting of the constraints. So how we can put particular component as a particular cell. So we can properly set successfully using grid bag layout is the proper setting of the constraints. So then only you can put particular component as a particular cell. So which are stored in grid bag constraints. Simply we can show these constraints are called as grid bag constraints. So it defines several fields. So first one is the default one. So next one grid bag constraints. So next one constructors of grid bag constraints. So grid bag constraints. Grid bag constraints constructors. First one is the default constructor. Next one is int gridx. So gridx means so it specifies number of columns on the component. It is grid by means it specifies number of rows on the component. Next one. Grid width means it specifies how many number of columns are there. Next one, grid height means number of rows. Next, width x, it specifies the horizontal space on a component. Next, into width y, it specifies width y means it represents it specify a vertical space of a component. Next one, anchor, where the position you have to put the component, it will specify. Next one, field. Next one, insects. Next one, ipad x, ipad y means so it specifies. So what is the positions we have to specify, how we can place particular component as a particular cell. So these constructor defines these all are the arguments. So next one data members. So gridx. So gridx means to specify the row position. Gridx means to specify the row position. In the previous slide, grid bag constraints constructors. So constructors of grid bag constraints. In the second constructor, so there are a number of arguments are there. Let us specify these arguments, these data members and purpose. So here gridx means to specify the row position. To specify the row position in the upper left region of the component display area. Suppose we have to specify one component in particular position. So suppose we want to put particular component in upper left position, then you can choose gridx constraint. Next one, grid. So to specify the column position on the upper left region. Next one, grid width. To specify number of columns in the display area of the component. Next one is grid height. Grid height means it specifies a number of rows in the display area of the component. Number of rows where you can put particular component is a particular place. Next we take, so it specifies horizontal sketch component to fill the display area of the container. The default value is 0. Default value starting from 0. Next one, grid wide. To specify vertical sketch of the component. So to fill the display area on the container. So suppose if you want to place particular component in a particular place, these constraints will help us to put one component in a particular cell and particular grid. So suppose if you want to vertical sketch of the component to fill the display area of the container, default value is 0. Next one, anchor. So anchor to specify the position of the component in a display area where the component is smaller than the display area. So it can specify the position where you can put the component, where you can place the component, where you can add the component, how we can add the component in a particular cell and particular grid. So next one, some valid value of anchor data members. So these all are the grid bag constraints. So how we can place the component? So value of anchor and placement of the component. Here let us see the one by one. So first one is grid bag constraints dot center. Grid bag constraints. So grid bag constraints dot center. So it is the anchor position where you can place the components in the center, north, northeast or west, west east, top, bottom, left and so on. So here center of the component. So we can place particular component in a center position. Next, grid bag constraints dot north. So these constraints specifies we can place a component. So north part of the container. So in a window east, west, top, south, and the center, left, right, top, bottom. These all are the regions. So where you can place the components, where you can put the component. Next one, grid bag constraints dot northeast. So these these positions specify northeast part of the container. In a similar way, grid bag constraint dot northwest, north south. So next one southeast, next one southwest, and east west. So these all are the constraints. These all are the anchor positions. So these all are the anchor positions to specify the components. Where you can place particular component as particular place. Where you can put particular component as a particular cell and particular grid. These constraints will help us to put one component in a particular place, particular area. So these all are the anchor positions: north, west, south, southeast, southwest, east, west. Simply we can say these positions as grid bag constraints. Next coming to the Next layout manager, card layout managers. Already we covered flow, border layout, flow layout. Next one, grid bag layout and grid layout. Finally, next layout manager is card layout. So what is card layout? So card layout means, so in the card layout, so only one card is visible at a time. So by using card layout manager, only in a window one card, it is collection of cards. So every component means every component we have treated as a card. So on a container, every component we have treated as one card. So every time only one card is visible at a time. Only one card is visible at a time. So we can simply say has. So in card layout manager, every component we have treated as a card. So it is nothing but collection of cards. But in a particular situation, only one card is visible at a time. So let us see the card layout class is unique among all other layout managers, so that it shows several different layouts. Next one, each layout can be thought of being separate index card. So it is a deck that can be shuffled so that any card on the top of the given tag. Suppose stack of cards are there. In the stack means first in first out. So we can pick up one top of the card only at a time, only one. So in the stack we can pick one card. So we can pick one card. Only top of the card is visible at a time. Only one card is visible at a time. So card layout provides these constructors. First one is it is a default constructor. It creates a default constructor. Next one, card layout into horizontal and into vertical. So here horizontal and vertical space left between the components. Next one, the cards are typically held on a object of type panel. So where you can place the components on a panel. So where you can place the cards on a panel. So panel means in the panel applet is a subclass. By using applet window we can put the components, we can add the components on a container. So container means it is like a place where you can add the components and where you can remove the components. So by using card layout manager, so each and every component we have treated as a card. It is in the card layout manager, each component is a card. It is nothing but collection of cards. At a time only one card is visible. Suppose we have stack number of cards. Suppose we have a stack. Stack means first in first out. So we have number of cards, number of components are there. At a time only you can pick up these these number of stack cards. Only top of the card is visible at a time. So here void add component panel object and object name. So how we can add the components and what is the object. Next one, methods. So void first, void last, void next, void previous and void show. So first means, so it contains of type of cards. First means these are the methods. So it represents, it specifies first component. It retrieves the first components. Next one, in the on a container, void last means number of cards. So we can pick up last card. Next means what is the next card. Previous means what is the previous card. Next to show means so it contains a container object. So it has two arguments. So whether deck and card name. These two are deck is a container type. So next one, card name is string type. So where you can pick the card and where you can put the components, where you can add these cards on a component. So card layout, simply card layout means so at a time only one card is visible. So here card means each and every component we have treated as a card. So it is nothing but collection of cards. Simply we can say as a deck of cards. So here number of methods. Suppose how we have to pick one card at a time. These methods will help us. First means first card is visible. Last means last card is visible. Next means next card is visible on a container. Previous means previous card is visible on the container. Show means it have two deck of cards. Next one is card name. What is the card name? And that means container where you have add the components. So each and every component we have to put inside the container. Here our container is a panel. So the cards are typically held on an object type panel. The cards are typically held in an object type panel. So it is nothing but layout managers. It is nothing but layout managers concept.